All right, we're going to take a look at some of the subtractive synthesis techniques that we've read about. We're going to take a look at those in Propellerhead's Thor synthesizer. Now, the way Thor, all of the Reason instruments are set to work in our computer lab at the school, we have our preferences and reasons set so that when you add a new device, it comes with a preset loaded. So that's the sound of the preset that came with this Thor instrument when I added it to the Reason rack. I'm going to press this button here to show the programmer, and you'll see when we open up Thor that this particular synthesizer sound has a whole lot going on. There are a whole lot of oscillators and a lot of modulation happening down here. There are different filters that are added and some delay effects. For this exercise, I want to reset the device. In other words, I want to create a patch that's basically emptied out of any of this fancy stuff, a very simple patch for us to start with. So we call that initializing or resetting the patch. I can select the Thor and then go to the Edit menu and choose Reset Device. Note that if you're using Reason 6 or earlier, this will instead say Initialize Patch. That's one way to reset or initialize the patch. Another way is just to find a blank spot where there's no knob or button or display on the device itself, and right-click, and the same menu will pop up. And again, we'll choose Reset Device. And that takes out all of the effects, all of the modulation from the modulation matrix down here, resets the sequencer, and it leaves us with one analog synthesizer and a low-pass filter. To really focus on the oscillator, I'm going to turn off the filter as well. So I'll click on this little down arrow and I'll select bypass. So now there's no filter. And we're hearing just the output of this oscillator unfiltered. It's got 4 selectable waveforms: sawtooth, pulse, which can be a narrow pulse or a square wave depending on the setting of this pulse width knob, square, narrow pulse near either edge. Have you ever heard of pulse width modulation on a synth? That is achieved by getting an LFO or some other parameter to modulate this pulse width. I'll do it manually here. I'll play a note and turn the knob so you can hear what pulse width modulation sounds like. All right, now you might have heard of that before. We also have a triangle wave and a sine wave, fundamental pitch with no harmonics above it. For our work, we're going to be dealing primarily with square pulse waves and sawtooth waves because those are harmonically rich. You'll notice there are also octave shift. There's an octave shift knob here. I can play a single note and shift the octaves up and down to select different range for the oscillator. Semitones or half steps. Again, I'll play a single note and adjust this knob. So these are coarse tuning knobs, and then we have a fine tuning knob. On Subtractor it was marked Cent, C-E-N-T. Here it's just marked Tune. Just tunes the oscillator up or down in small increments, used mainly for detuning two oscillators from one another to create a kind of chorusing effect. So that's the analog oscillator. I'm going to turn off its output with this button number 1 that's red. I'll turn it off. And then I'm going to turn on oscillator 2. And down here in that oscillator 2 slot, we'll add a second oscillator. Click the down arrow, and we see a list of many different types of oscillators. We'll talk about some of these in other tutorials, but for right now we're focusing on subtractive synthesis. So that in this device entails usually the analog oscillator that we just looked at, and this multi-oscillator. Let's take a quick look at that. Again, it's got waveforms that look familiar to you, I'm sure. But it already sounds like something's going on, doesn't it? It sounds like more than one oscillator detuned from one another. That's because of this feature right here. You'll notice these knobs are pretty straightforward: octave shift, semitones, and fine tuning. But this is new. This is something different. And what this multi-oscillator does is it produces the sound of multiple waves at the same time. And then there are different schemes for detuning them from one another. It's currently set, the default is to random, and there's an amount knob. So I can go from very dramatic, chaotic, you might say, amounts of detuning, all the way to no detuning at all. Now it sounds like a single sawtooth wave. Okay, or something in between. You click on that field there, and you can select different detuning formats here. Let's tune it to a perfect fifth. So it'll sound like two waveforms tuned a perfect fifth apart from one another. All right, what else? How about an octave? And it's kind of fun. So again, the multi-oscillator sort of sounds like multiple versions of this analog oscillator plugged into or playing at the same time. For the rest of this tutorial, I'm going to focus on the analog synthesizer alone. Or I keep saying synthesizer, I'm sorry, the analog oscillator. And in the next tutorial, we'll take a look at some filters. All right, that's it for now.